Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at the rules for networking. We'll be discussing communication fundamentals, communication protocols, rules establishment, network protocol requirements, message encoding, message formatting and encapsulation, message size, message timing, and also message delivery options. This episode is part of my series on Introduction to Networks. I'm Kevin. This is KevTechify. Let's get this adventure started. How we see the network is a nice little logical diagram. We have end devices. We have these PCs here. We have intermediary devices. This is how we see this. We can envision the whole thing, the whole network. And on these devices, we have all sorts of different settings set. These are different protocols. We have MAC addresses for our Ethernet, for our wireless. We have IP addresses, IP version 4, IP version 6. We have some default gateways, how we move messages off of our network. We have DNS servers to figure out where domain names are associated with IP addresses, because once again, traffic does not travel across the network using domain names. It travels across using IP addresses. How the device sees the network is basically the device is in a bubble. It doesn't see any of the other devices out there. It has protocols to allow it to communicate out there and then figure out where to go, but it doesn't know about all these. It lives in its own little bubble. And so that's the idea here, is the devices are in the bubble. We don't know a lot about everything else, but these protocols allow us to find out stuff and move data across there and get us to that information that we want. Now, these devices have the protocols running on them, and these protocols are designed in such a way to facilitate it. Each one does something a little bit different. They all work together to get us to our end destination. And so we see that each device has its own little bubble, but it's running all these protocols. And look at this list of protocols. This is run on just about every device on your network. All of these. Yes, we have IP version 4, IP version 6. You may be running one or the other or both. But looking through here, most of these protocols are existing on your network, whether it's a corporate network or your home network at this point in time. Now, when we talk about communications and getting that data across there, we have to understand stuff. These networks we're talking about can be all sorts of sizes, from your local area network at home to corporate networks that span multiple continents. So we have to have, these protocols have to work together and in such a way that we can have different sizes of a network. And it's just not enough to have what we call a connections. They must agree on how to communicate. And we're going to talk about some of these different things in the protocols and the ideas coming up here. Now, there's 3 elements to communication. You need to have a source, you need to have a destination, and a way for those two to communicate. If you think about that, you're talking to your best friend, right? You're the source. You're going to say a message, then that message is going to go across the medium to your best friend. Now let's take this example here. Here Serenity's walking around, it's noon, she's hungry and going, I'm hungry. She looks over there and says, hey, that's my brother Wyatt. I bet you he's hungry too. We could go to lunch together. So Serenity asks him a question. So she has this idea of, hey, let's go to lunch. And she then verbally says, hey, let's go to lunch, Wyatt. I'd like cheeseburgers today. And so that message travels through the air using sine waves. Wyatt receives that in, decodes that and processes that and says, hey, Serenity's hungry. She invited me to go eat. I'm hungry too. Let's go. And so that's how it works. If we diagram this out a little bit more, what we can see here is we have our message. That's, hey, I'm hungry. It's time to eat. There's Wyatt. Let's do that. We send a signal. We transmit our signal. It goes across a medium, which was air to start with. And then that signal is received, and then we decode it. And so we have this process here of sending that message. Now, not only do we do that, but Computers do that same thing. They take a source message. Hey, I want a web page. We convert that into a signal. We transfer it across our network. Gets into the server receives that, and then the server decodes that and says, hey, they want this web page. And then the whole process starts over, but in reverse order. Going from source to destination, now the web server is that source going to the destination. Now, when we talk, we have rules in communications. We look at how do we send the message, and there needs to be some sort of order. Now, if I gave you this message, just take a look at it. Humans, communication between, govern, rules. It is very difficult, and there's no spaces in some of this to understand messages. And then as you read through this, it's a little hard to read. And then all of a sudden, it's in a different language. We all of a sudden see that we're all over the place. We're using all these grammar and rules, and the words are out of order. Capitalization is wrong. It's completely wow. It's completely all over the place, and it just doesn't make sense, and it hurts to read it. Now, let's take these rules that we've learned since grade school, all the way through high school, rules of grammar, apply to this, and look at this. It's now a readable sentence for us humans. We have these rules that we learned in grade school, in English class, on how to write sentences. This is what rules we're following at this point in time. Now, for communications, to establish rules, we have to identify some stuff. We have to identify who's the sender, who's the receiver. Serenity was the sender to start with, asking her brother Wyatt was the receiver. Your PC, when you put that web address in there asking for that web page, that's the sender. We're going to send that information. It's going to go across the network. Web server is going to get that request. They're going to receive that request from you. We need to use a common language and grammar. We need to use the right words and the right punctuation to have it make sense to us. We also need some speeding and timing of the delivery, right? If that message, if Serenity sent that message to her brother Wyatt about her being hungry, and it took 12 hours to get there, Serenity's probably not hungry then. Definitely Wyatt has eaten twice since then. And so that message is delayed there. And so it's not going to help anybody there. And then we need to get some confirmations or acknowledgement. Yep, I heard your message. That sounds like a great idea, Serenity. Let's go out to eat and get some hamburgers. And so we need to look at these different requirements there. Sender, receiver, common language, speed and timing, and the last one is a confirmation or acknowledgement. Network protocols have their own requirements. Looking at this is, how do we encode this information? There's a number of different ways to encode this information. Right? Think about a JPEG or a picture. You can encode it as a JPEG, as a TIFF, as a RAW file. Those are all different encoding methods. Each one has its use in different places. Talk to somebody who's into digital photography, and they will tell you that each one has a different place in their usage. Same thing with networking protocols. They have different places to use that different encoding. How do we format and encapsulate it? Formatting is do we put the verb first or the noun first? Do we put the command in the argument? How do we do that? And then encapsulation, maybe we put some information at the beginning to help us process that. Message size. We think about sending a big movie across the network. Well, that's not going to go across the network in one piece. We break it down into size. Then we have timing. You should be listening to get a message here all the time. But then when we start sending you this big file, you should be expecting pieces on a regular time interval. And also, what are my delivery options? Am I going to use wired or wireless? What protocol am I going to use? So looking at these are all different network protocols that we're going to use. Now, message encoding for computers does sort of the same thing. We look at here, we have the message source. So where is it starting? Then we have encoder. So we encode it some way. We take in you put www.website.com in your web browser. We take and then we change that into something the computers will understand. Ones and zeros. So we translate that down. Then we put it in our transmitter, your network interface card, your NIC. We send it across the medium. Ethernet, copper, fiber, wireless, whatever it is, and then the receiver hears it, gets that message in, decodes it, turns it from ones and zeros into something they can understand, and then processes that message. And so we have this process happening continually for us. Another thing we have to think about is encapsulation. Let's say grandma wrote you a nice little birthday card. She wished you happy birthday. In there, she put a check for you to cash. She said, go out and have a good time. She put that check in the card, but then what do you do with that card? You can't give it to you. Grandma's living in Florida. You're at home. So that's not going to work. What we have to do is we have to put it inside an envelope. We encapsulate it in paper. And then part of that encapsulation process is we put our source and destination address in, who it's from. It's from grandma in Florida. It's to you at your house. And then we put in maybe some other information, like a stamp, so the post office will deliver it to you. So that's all part of the encapsulation. In a lot of communications, there's multiple encapsulations. So you got envelopes inside of envelopes as we're looking at that. If you like this episode on the rules of network and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment, subscribe to my channel. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Typically, a message is formatted and encapsulated by putting some additional information at the beginning of it. You can kind of picture it like a train. The data is the cars in the middle. So the cars in the middle, they're holding all sorts of different cargo. It could be grain, it could be coal, whatever they're hauling there, that's the message. But then the engine supplies the power, knows how to get to its destination. So that is the header. That is the piece of information at the front of the train. That's what the cars are encapsulated with. Sometimes there's a caboose, sometimes there's not. And sometimes they put a trailer, that's what we call that last piece of information on the end of your data. Sometimes there's a trailer, sometimes there isn't. But here's an example of a header that we put at the beginning of a data when we encapsulate it. So what we're doing is we're taking our data and we're putting a front and sometimes a back on it. We're encapsulating that data. And don't be scared of this diagram. This diagram is not overly complicated. Now, let's talk about this layout here. Right here, we have 4 bytes across, and then it says it's 40 bytes tall here. What happens here is there's bytes here. Between 1 here, this is 1 byte of information. And to review, a byte is 8 bits of information. So inside of here, there are 8 ones and zeros in there. Somehow, and those signify something based upon their values and where they're located. But you go across there, each one of these bytes have 8 ones and zeros, so there's 32 bits going across here. Now, they say there is 40 bits in this total thing. If we look here, between here and here, that's 1 row. So there's 1, 2, 3, 4 bytes going across here. The second row, there's 4 bytes. So that's 8 bytes. So that gives us 32 bytes. Divide that into 2 sections. That's 16 bytes for the source IP, 16 bytes for the destination. As we break this down more, there's 4 bytes there. So there's actually 4 rows of bytes in here for our IP address. Same thing here. And it's all ones and zeros in there. But understand here that this here, for this little square right here, this is the version number. So are we using like IP version 4 or IP version 6? There's values in there that indicate what we're using. Then what traffic class are we using? There's a value that represents different classes. So that way, when you receive it, you know what you're receiving. Is the message in English? Is it in German? Looking at that. Then we have each one of these fields. So these fields are identified by that. Looking here. And so we put this information at the beginning. This information of ones and zeros, they signify how we process and how we receive the information. Think about a file you're going to send across your network. It's 4 gigabits big. There's lots and lots of information. The chance of it actually going across your network or even across the internet is very slim in a big format. What we do is we break it down into smaller chunks. Then we send those smaller chunks out there, and those chunks have a better chance of survival through your network. Now, if you have the one big file and one of those in one little 1 or 0 gets messed up or gets lost, what you have to do is send the whole file again. But if we break it up into smaller pieces, then we just have to send that one smaller piece. Hopefully in the long run, it's a more efficient process to do that. Okay. Message timing has 3 components: flow control, response timeout, and access method. Flow control deals with the rate at which data can be sent. So how fast? Am I on a 10 meg connection or a 100 meg connection or a gigabit connection? Am I talking too fast in this video or just at the right speed? I have a tendency to talk too fast because I get excited about my topics. And so maybe I could slow it down a little and put some pauses in there. Information, how fast can we send information? The computer can send at a certain speed and listen at a certain speed. If we overload that, your information is basically lost. Response timeout. How long do I wait to hear a response back? Right? We've had conversations where you've said something and you asked a question and you're expecting a response. So you sit there and you wait. How long do you wait? 5 seconds, 10 seconds? Do you wait a minute before you go, hey, did you hear me? I didn't get a response back. And so that is that timeout. The protocols establish how long do you wait for that. Then the access methods here is determines when can somebody send a message. When can they put information? When can they put 1s and 0s on that medium? Now, we typically have 2 ways of doing it, is either collision detection or collision avoidance. And we have an episode coming up that gets into the details of that. But what we're looking at here is how can we send information on that media? So these are the 3 things that we look at for message timing. Message delivery option. For delivering messages, we kind of have 3 different options here: unicast, multicast, and broadcast. Unicast is the one-to-one broadcast. That would be you pick up the phone, you dial grandma, thank her for that birthday card. It's just you and her on that phone. That conversation is happening between just you two. Nobody else is there. It's a one-to-one. One computer is talking to another computer. Your client is querying a web server, and that conversation is just happening between your 2 devices. That's a unicast. Multicast is a little bit different. Multicast is there's one computer broadcasting, and then there's several people listening to it, but they're purposely listening. They're subscribing to that. This would be a Twitch streamer or somebody streaming online where they're streaming, they have one stream, it starts, and then if you want to listen to that streamer, you go to their web address, you put it up, and you play it, and you can listen to it at that point in time. Now, normally with this multicast, there's no ability to go backwards. You can't rewind it, you can't pause it at that point in time. Broadcast is the next evolution in this message delivery. This is where there's one source broadcasting to everybody who can hear them. Regardless if you want to hear them or not, you're going to hear them. This is the instructor in the classroom talking to the entire class. If you're in that classroom, you're going to hear your instructor talk. Now, I do want to talk about something. I'm going to go back to multicast. Well, some people say, hey, Netflix is a multicast. A lot of people can watch that movie. You have to pay for your Netflix subscription. Actually, what it is, Netflix is a unicast. It's a one-to-one process. And the reason for that is, think about it. Netflix, I can start a movie and start watching it. And then you want to watch the same movie, but you're eating supper, so you start a half an hour late. You're not going to start watching where I'm at in the movie. You're going to start watching from the beginning. And so those are 2 separate streams that are happening. So that's something to pay attention about. Even though it does look like it could be multicast, it is actually a unicast. The idea here is if I can start it when I want and I can pause it and I can rewind it, that is typically a unicast process. It's not a multicast at that point in time. So pay attention to that one. Okay. It was my pleasure to provide you with this wonderful episode on the rules of networking. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Network. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.